Hey folks, my name is Luis Quintanilla. I am a product manager on the dotnet team, specifically focused on AI libraries and AI platform. Um, and so I've been in the team for quite some time, even going back to the days of ML.NET when we were doing, AI in a different way. Still AI, but just not the generative AI. In fact, hadn't been quote unquote invented then, right? Transformers was just coming out, the paper, attention is all you need. But anyway, been around the space for quite some time. Most recently spent my time working with the team on a set of libraries and building blocks that I'll be talking to you about today. Just generally or colloquially, they're known as MEAI or Microsoft.Extensions.AI. But that whole universe, right, over the past few years has continued to expand, to continue to fill the different sort of building blocks that you need as a developer to build AI applications, right? And so, as I mentioned earlier, you probably heard extensions AI mentioned many times throughout the other sessions, right? And the reason for that is because extensions AI, as I mentioned, is the building blocks that that the rest of the ecosystem builds on top of. So let me kind of start off with something that you're probably all familiar with. You open up ChatGPT or Copilot, Claude, or your chat interface or agent of choice, and you go ahead and you ask a question, right? And goes, you send a request, it comes back. You don't really set anything up, and then you get a response, right? Oftentimes, the AI assistant that you're working with tends to be a little bit overconfident. It'll make stuff up, right? There's some issues, but generally speaking, you're gonna send a request. It's gonna come up back with a response. Um, and it feels like you're just talking to a model. And when it's sort of like the base case, that is true. You're typically just talking to a model. But again, right, like the model itself, there's only so much that it can cover and handle, right? And so again, things that you may run into is that it makes up facts primarily because it either doesn't have the right context, it doesn't know about your data. Probably, for example, most likely, if you were to ask, certainly the smaller models, right, you were to ask them about the World Cup, what's the latest scores, right? It wouldn't know about it because the training has been cut off, months in the past. And more importantly, right, the models themselves can't take action. They just provide, text in, text out, or given some input, they produce some output, but they can't themselves actually take action on your request, right? And so even though as an end user, it seems like, oh, well, I'm just sending a call to this system, that system typically being the model, and then I'm getting a response, right? It is, but it's not just one call, right? It's a call to the model plus all of these other building blocks that really make, talking to these AI systems, reliable, safe, trustworthy, and all the things, right? And so with that, it kind of is gonna. This is how our talk is gonna shape up. So basically, every AI app, as I mentioned, needs a handful of primitives, right? And so we're gonna cover how you need a way to talk to models. That's sort of the base case. But then you also need a way to provide it with your own data, right? Need a way to call tools and for it to take action, your AI assistant or your application to take action on the user's request. You're going to need some cross-cutting concerns, right? You're going to need observability to see what the system is doing at each step of that request chain, right? You're going to need to evaluate your agents, right? And you need to be able to understand, is my agent, is my AI application good enough for whatever definition of good you and your team sort of define, right? And then last but not least, you're going to be able to orchestrate these agents, right? So you probably saw in the previous session with Squad, right? The orchestration is a big component, and where it really, these systems tend to get really powerful, which is orchestrating not only the agents themselves, but also composing and orchestrating the resources that they use. So again, the tools, the data sources, the models, and all the components that these agents need. Right? Um, and so we have a set of primitives that we're building in .NET, and one of the things that we want here is we want them to feel native to .NET, right? So we ship all of these things that you're going to need for your application as primitives, and so where possible, right? If you're already familiar with patterns like the builder pattern and middleware and logging and OTel, dependency injection, right? A lot of those patterns are reused, and we try to make these primitives feel native to the platform, right? So a lot of the skills that you already have, right, just kind of tend to carry over to when you're building with these different primitives for AI. Um, and then more importantly, because we're reusing a lot of the same patterns and these are .NET first primitives, right? That means that you can just plug them into any application. So, your Blazor apps, backend APIs, MAUI, right? Cloud native applications, right? It really is just .NET. And so the integration becomes, fairly seamless. So again, we're going to kind of go through this talk through the various building blocks that establish the foundation for building AI apps. And so at the top, you're going to see agents, right? And we're going to talk a little bit more agents towards the end. But at the end of the day, right, the agents, you can kind of think of them as the app platform that then leverages all of the other foundational layers under it, right? And so as we walk through the process of building an application with AI, right, we're going to be going through each of these blocks. There are some samples. I can share the repo, after this talk, but both the presentation and the samples that I'm going to cover are there. And so you can kind of take a look at each of these, building blocks on your own time. All right. But before we get started, I think I've sort of alluded to it, but what do we see as our role as a .NET team, right? And so I could tell you from my perspective, the role that we have taken on in this AI space at the platform level, at least, is we play to our strengths, right? And so very few ecosystems out there, have a steward, right, like Microsoft behind them. And so we really take that, responsibility. We take it seriously, right? And so one of the things that we are tending to do with by shipping by shipping these primitives is by authoring the interfaces and the contracts. So in things like the IChatClient or the embedding generator or the vector data abstractions or data ingestion, right? All of these different building blocks, we are just providing the seams and the foundations and the contracts, um, so that then the rest of the ecosystem can go ahead and build on top of them, right? And so you see this pattern play itself out time and time again, right? Whether that's, middleware in ASP.NET or entity framework providers or, loggers or, distributed caches, right? We establish the contract at the platform level, and then the rest of the ecosystem, right, provides their own implementations. And so when it comes to the AI space, right, that means that regardless of whether you're using OpenAI or Azure or Ollama or insert provider of your choice, right, because there are implement these those are concrete implementations of our abstractions, it's relatively easy for you to pick and choose, and sort of get started more quickly and accelerate the adoption of these systems, regardless of the provider, right? Because you're programming against a common set of abstractions. And so, again, what do you get? So, as an end user, as a developer, right, what you get is that there's very little to no lock-in because you're programming against abstractions, all of which are implementing, these building blocks, right, these primitives. You can, for the most part, swap a provider without having to do a major rewrite and without having to learn a brand new set of APIs every time that you want to switch, either switch providers, or introduce a new provider into your workflow or application. As mentioned, these primitives are, for the most part, they try to be native to the .NET patterns, and so a lot of the tools and a lot of the patterns that you're already using inside of your applications, right? These plug right in. Again, because there's a single interface, you can, for the most part, just reuse those same patterns across the board. Where possible, right? So in cases like MCP for tool calling or OpenTelemetry, specifically the generative AI semantic conventions, right? We try to align with those conventions so that your applications take advantage of all the tooling and libraries, right, that support these open standards. And then sort of as, so that's as a developer, right? But if you're thinking of it as a library author, right, again, it allows you and your library to plug into this rich ecosystem without having to build, the pieces yourself or having to program for every single provider that's out there, right? Okay, so With that, let's kind of start with the chat client, which is this is the foundation for really the rest of the the stack, especially when it concerns talking to AI models. And so the IChatClient, as I mentioned, it has different provider implementations, and so that means that you can use an IChatClient, the interface with providers like GitHub Models, Azure OpenAI, Ollama, Foundry Local, right? And you can use all those through the same interface, right? And so you're going to see that in this code sample, right? This first sort of line of code here with OpenAI client, what that's doing is it's effectively just doing the setup, like setting up your credentials, your tokens, right, for OpenAI. But then the OpenAI itself, we have a set of adapters, right, that enable you to take this OpenAI provider and then convert it into an iChat client. And then from there, you just call, from this point on, in your code base, you effectively just call this get response async and the set of methods, right, that iChat client provides you to interact with the models, right? And so if you want a different model, you can effectively just change, the model name here. If you want to change, providers, right, you effectively would, change more or less what, how you construct the provider. But then the rest of your application code that invokes this chat client just, for the most part stays unchanged, right? So the rest of the application, there's not this major rewrite that you need to go do just because you're switching a few things in terms of your implementation, right? And so this is the thing that then everybody else or the rest of the ecosystem kind of builds on top of, right? And so, if you were to send a request in one sentence, what is .NET, you get something like this, right? And so again, the power here is that it's provider agnostic. There's one interface that you can program against. Now, to kind of illustrate the model swapping, right, you can see here that now we're using Ollama. And so if we're using Ollama, this is how we would construct it. But Ollama, the Ollama Sharp set of libraries, provides a native implementation of the iChat client. The thing to call out here, though, right, is if this chat get response async, is exactly the same as this one here, right? So as I mentioned, your code doesn't change much. Obviously, the response is going to be a little bit different because different models, but again, right, your core application code does not change, right? Regardless of whether you're using offline small models or the cloud-based models. Okay, but is it all just text? And the answer to that is no, right? And so the models can handle different set of modalities, so meaning images, audio, text, right, and things like that. And so if you look at this sample here, we're still using a chat client in this case, right? And in this case, we're using this data content type. So again, supports various types of message types. And so in this case, we're just saying, hey, what's in this image? We provided an image. And then provided the image bytes, and then just send call get response async. And what this is going to do is, if a model has vision capability, it's going to go and analyze the image and produce a response, right? Kind of like the one that you're seeing here. And if you need to, for example, put text in and then generate an image, right, we have this other interface called an IEmbeddingGenerator, which, as the name kind of implies, will generate an image based on the text that you provided, right? There are other sort of abstractions that we have. So we have things like the speech client for sort of real-time speech, right? And so the point here being that the set of extensions.ai primitives, while chat client and text-based tends to be the primary modality, is not the only one. And we try to cover, where possible, the most, the most important ones, and where there's a lot of, support for in the ecosystem. So, all right, so that covers models. Now, as I mentioned in the beginning of the talk, right, the models themselves don't have access to your data. And so you need a way to search through the data that you have for, your enterprise, your personal data, whatever it may be, in order to, in order to provide, relevant context to the models, right, for it to generate, accurate or at least timely answers. And a lot of that kind of starts with embeddings, right? And so embeddings themselves, you know, what they allow you to do is they allow text primarily, though you can, like, with the other examples, right? There's image embedding models and things like that that effectively turn an input data source into a set of numbers, right, that can be searched on, right? And so here, for example, we have this IEmbeddingGenerator, which is one of the abstractions that Extensions AI provides you with. And then, we have this IEmbeddingGenerator. And if we were to generate an embedding for I build .NET apps with .NET, and then we're to build, this other embedding for .NET as a developer platform. If we were to compare, for example, .NET apps and .NET platform, we get a relatively high score of, 5, 6. And then if we were to compare the text .NET apps and cat sleeps, we get a lower score here, right? And we're actually using the tensor primitives set of building blocks, which we also provide, as part of the libraries and building blocks in .NET. We basically do a comparison, right? Compare, one piece of text to the other piece of text, right? And then tell me, how close or how similar they are. And so this is probably like a better illustration here, right? And so embeddings, they basically map text or data to some sort of point in space, right? And allow you to, again, do those comparisons to see, okay, .NET apps and .NET platform, they're close to each other. Cat sleeps is not, right? And so when you're doing search, trying to search for relevant information to get, to sort of provide an answer to your question, right? It's leveraging embeddings, right? And embedding vectors to perform that search to find that relevant information, right? And so the general process, right, is through retrieval augmented generation. Let me actually come back to this, and for folks who may not be familiar, right, RAG or retrieval augmented generation, basically what happens is you submit a question, you retrieve relevant facts from some data store, you inject them into the prompt that you sent to the model, and then you generate an answer based on that data, right? And so this process, typically you have to do this manually, right? But with the vector data set of abstractions, right, we provide you with some nice features where you don't have to go and do this yourself. The sort of the retrieval, the searching, and all those things are sort of done for you. All you have to do is, for example, if you have, let's say docs is your data store, you call on the search async method. And again, regardless of whether you're using, in-memory data stores like SQLite, or you're using native vector stores like Quadrant, or you're using Azure AI search indices, right? There are implementations of the vector data set of abstractions, right? So all you need to know is, well, I need to call search async on whatever my query is, right? Return the top results, and then use those to generate an answer with my IChatClient, right? That get response async, right? And so and then what you would end up with is, well, here's the results, right? Here's the facts that were inside of my data store. And then, here's what the actual response would generate after you send the data plus your original query to the model to generate that answer, right? And so vector data kind of helps you, simplify a lot of that stuff by providing you with some of those convenience APIs. Search async under the hood, what this is actually doing is it's taking your original, it's taking your original query, turning it into an embedding, looking at the embeddings of all the different facts inside of your data store, and then doing a ranking to return the top and most relevant results, right? So so a lot of this stuff, right, just kind of you don't really need to do. You just give it your question. This part kind of like the vector data set of abstractions, for the most part, handle for you, and then out the other end comes the grounded answer. So that covers the data and ingestion pieces. So the other thing that I sort of talked about, right, is that the models themselves don't or can't take action. And so again, that's one of the things that we provide with the extensions AI set of primitives, right? So what you're going to see here is inner in this case is a chat client, right? And then what I do is using the builder pattern, I basically use middleware. And in this case, the middleware is this function invocation middleware. What this will do is, given a, C, in this case, it's a C# method, right? That just returns the days until whatever date that you specify. You can expose this function, right, or this method as a tool for your AI model to call on, right? And you can say, hey, model, I have a set of tools. In this case, it's this days until. The AI function factory under the hood will go and figure out what the parameters are and basically construct what the model needs in order to make this request or to figure out, hey, this is a tool that's available to me. And if I ever need to know, how many days, or there's a query asking how many days until, this month or day or whatever, right? Use that to try to answer questions or take action on something, right? And so again, then once you've sort of configured your tools here, then the pattern is pretty much the same. You say chat, get me a response. Here's options, providing the set of tools. And then the model can go ahead and leverage this, right? Because the model itself doesn't know what time it is. As I mentioned, it's sort of like it's frozen in time and it can't take action. But things like this kind of help being able to expose tools, whether that's code itself or I'll talk about it a little bit later, MCP tools, right? It helps the model it helps provide the model with additional context and capabilities from the ability to take action, right? And so you might see as the output to this request, right? If somebody asked, how long until December 25th? This was yesterday, right? But this is the response that you would get. And it's grounded, again, using these tools. And both the middleware functionalities of the IChatClient, make it really easy for you to sort of expose your code or make your code available for the agent to call upon. And so again, right, how does it know to run your code? It basically, the model just, takes your input text, right? And because it knows that it has a set of tools, meaning like it's injected into the console, like, hey, these are tools that are available to you. If you asked it about how many days until, December 25th, it would figure out, 12/25 is the parameters, right? If you remember correctly, you needed the month and the day. So it'll parse through your query. It'll then map it. The model will then map it to the parameters that need to happen. And then it's going to do an invocation of your C# method using the right parameters. Generate that, your code will output a response. And then the response is then sent back to the model, which is what the model then uses to, to go ahead and generate the response for you. Right? Now, that's all well and good if we lived in a world where everything is built in .NET and C# and everybody's using extensions AI. But the reality is, right, systems are built with different tools and different systems and things like that. And so, here comes MCP, or the Model Context Protocol from Anthropic, right, which has effectively become an open standard. I want to say 2 Novembers ago. It's been a while. Time is blurry, but long story short, right? The long story short there being is that the MCP has sort of become the standard for exposing tools to external systems that may not have been built in the same language or with the same stack or even in the same system, right? And so again, so a few things. One, the MCP, so that same sort of AI function factory capabilities for tool calling is actually the same set of primitives that powers the MCP C# set of SDKs. And what that means is, in this example, for example, I'm using, I'm effectively establishing an MCP client, right? So something that can call on some ACP server that's out there somewhere. In this case, that MCP server is a Microsoft Learn MCP server, right? But under the hood, it's leveraging extensions AI set of primitives. And so what that means is, if we kind of go back here, notice how when you register, you say tools, and it's a list of tools. When we switch over to MCP, right, you can see that you can just say, hey, here's my MCP client, learn, get me the tools. And then those same chat options, we just pass the tools there directly, right? So all the tools, in this case, doc search, code samples, and fetch, right, are all available to my chat client with the simple call. So again, the primitives sort of compose, right, to make these integrations feel seamless, regardless of what provider and what it is that you're using, right? So it really makes a cohesive narrative across the board and a set of reusable patterns. And so again, what is MCP? You have your app. In this case, we have a client. Of course, you can also implement the server itself using the MCP C# SDKs. But in this case, we were just using it as an MCP client. This Microsoft Learn server, MCP server is out there somewhere with a set of tools. And MCP is the thing that makes it easy for us to go back and forth in the context of your application, right? You're still using the IChatClient for making calls to your LLM. MCP is just providing that tool calling capability um, and additional context for your model, right? So again, it's that one standard. Effectively, that's like a USB-C standard. And then once you have this in place, you can effectively call upon all of your different MCP servers that you have out there. So that covers tools in MCP. And the thing with the IChatClient, right, if you haven't noticed by now, is that it effectively follows this kind of pipeline pattern when it comes to middleware, right? And so you're going to have cross-cutting concerns across the board. And so similar to ASP.NET Core, right? If you built ASP.NET Core applications, you may be familiar with sort of the request pipeline or the middleware pipeline, right? And so if you were to look at an IChatClient, it's fairly similar, right? So we covered the function invocation piece, right? But there may be other cross-cutting concerns like caching and what's it called, tracing, right, with OpenTelemetry and observability. Um, and the way that the chat client works is effectively the same way, right? So you can read these top down, right? Depending on which capabilities you need from your agent, you can just kind of like continue to append to them, right? And if one doesn't exist, right, you can effectively create your own, right? So even if it's not provided by Extensions.AI, you can extend the system, right? These primitives and interfaces are open, and so you can go ahead and implement your own. And so whether that's retry logic, whether that's scanning for PII information, whatever it is that you need to plug in to intercept the request as it's going through this pipeline, you can sort of effectively do that, right? And the pattern again is familiar if you've done some of this middleware pipeline type of work before. Right? So that kind of covers the middleware and observability piece. Okay, I'll pause here in case there's any questions. I don't see any in the chat, but not sure if that's okay. So how do you know? So it's great, right? Like, let's say that you've built your application, you got your agent, you got your tools, you got your data stores that's providing context and all the latest data to your AI app. Everything is set up set up nicely, right? And your app is ready to go. You shipped, you're live in production. But how do you know that your system is good? And more importantly, how do you know that it stays good, right? So for example, right, the world is always changing. And one of the one of the examples is no longer, I guess, relevant, but like really the stark contrast of this was, for example, um back in the day, when sort of COVID happened, right? Like, imagine that you were a hotel chain and you had basically done all this capacity planning and you had everything laid out for, your 2020 targets and, the things that you were trying to hit, right? And all of a sudden the world changed, right? Like, we got COVID and then, not a lot of folks were traveling, right? And so that's kind of like an extreme example of how the world changes. But the products that you're selling, the preferences from your customers, right? Your internal policies change, right? So the world is always changing. And so how do you know that what you shipped is still relevant? It's still providing, grounded answers based on the new state of the world, right? And that's where evaluations come in. And surprise, surprise, right? Evaluations builds on top of the extensions AI set of primitives, the IChatClient, and everything that we provide there, right? So this is effectively a library that sits on top and builds on all those set of primitives, right? Um, so so you can see here, right? So we have a set of evaluators in this case. You have an interface. So if, again, very similar to the chat client, or the middleware patterns, right? If there is an evaluation, custom evaluation that you want to go build, you can certainly go and implement your own. In this case, what we're using is this composite evaluator, which, as the name sort of suggests, right, it takes a number of evaluators and then tries to come up with a measure for what quote unquote good is, right, based on whatever threshold that you're setting. And so what you end up with here, now we're using a lot of the built-in ones. So this is the relevance evaluator, coherence, and groundedness, right? And then once we have our evaluators in place, we just call an evaluated sync, and then we have the conversation. This is the chat that you've had between you and your AI assistant app. You have the response from the model, right? And then you have a judge, right? So effectively, you're leveraging another AI model. Typically, the preference or the recommendation here is that, for example, let's say that you wouldn't use say one of the smaller models. So for example, if you're using Claude, right, you wouldn't use Haiku, or you wouldn't use one of the mini models to be the judge. Effectively, you want a powerful enough model here to act as a judge of a conversation, to sort of really analyze and reason through, right? uh is Are the responses that this model, or that this AI app is effectively creating, are those responses meeting the criteria that has been defined by you and your team, right? And so it gets the evaluation results, and then at that point you can then just go ahead and get the individual results. So you can get things like the values and things like that, and then you can just print them out, the relevance, coherence, and then based on this, right, you can then take action. So here's where you would go ahead and perform some sort of improvements. You would maybe tweak the prompts. You would maybe improve the descriptions of your tools, right? You might even switch models. Maybe if you switch to a more powerful model, you may get better results, right? But what the evaluations give you is they really allow you to diagnose what places, in addition to observability, right? Observability plus the evaluations give you the ability to then go ahead and take action towards improving your AI assistants and your AI agents, right? And then just again, just an overview of how this works is, again, you have the answer, right? You have some criteria, um, and that criteria plus the evaluators, whether that's relevance, coherence, groundedness. There's many others out there, right? Um, Plus the evaluator and the criteria that the answer is being evaluated against, plus the ground truth, right? Because you want to know, like, what actually am I expecting? So for example, let's say you have a conversation and it's a customer support agent for I don't know, like e-commerce site, right? And in the conversation, if somebody asks about, you have this mode, it's like, if somebody asks about returns, go ahead and pull from the our return policy and ground on the make a tool call to return the tool policy, sorry, to return the return policy, and then provide an answer on that, and then don't address unrelated questions, right? Maybe that's your criteria that you're setting, and you define what the ground truth, like what would you expect somebody to say? It's like, oh, our policy is 30 days, blah blah blah, right? But then all of a sudden, if the model is return, if somebody were to ask it about how to cook steak or whatever, right? Like, you would have that ground truth plus something that's relevant, your criteria, to then be able to say, like, hey, if your model were to go ahead and respond to that request, right? Then that's something that you may want to sort of the evaluations would surface that something's wrong, and then at that point you would effectively take action on that. Great. So that's evaluations. And so finally, right, all this time we've sort of been building up and going up the stack, but ultimately we end up culminating with agents, right? And so I'm sure you've seen many definitions for what an agent is. I'm not going to try to define what an agent is, but what I can tell you is that effectively an agent encapsulates, right? So that's why I was talking about, like, hey, an agent, you can think of it as a process or like the app layer, right? because it encapsulates all of the different pieces that we just talked about, right? And so when it comes to the .NET ecosystem, right, you have the Microsoft Agent Framework, which actually builds on top of the iChatClient and all the primitives that we've been talking about before, right? So like all that was to say like, hey, here's the foundations. But ultimately, when you culminate at the agent level and that sort of application level, all the stuff that you've used before, all the things that you're familiar with, right? They all of a sudden just plug right in, right? And so, if you when we're talking about the model, right, the iChat client is the one that sort of comes into play when it comes to tools and providing tools to an agent. That's done through the AI function factory and the AI tool set of primitives that it provide that we provide in Extensions AI. For our memory, it's an A context provider, so that's more of like an agent specific one. And in instructions, right, that's just your prompts, right? But the tools and the models and the data, right, in many cases, it's the primitives that are powering those. So you're able to, just plug right in. And so the agent itself also has, reasoning, acting, and capabilities to observe, right? And it also includes session management and things like that. So it does encapsulate a lot of things, but ultimately it builds upon all of these building blocks. And then you can get even more fancy and then take the agents and compose them into blocks, right? But again, all of that is happening because of the primitives and the building blocks, right? And so how exactly do you build an agent, right? So let's say that we've all this time we've been here talking about, we have this, chat get response async, right? So this is just our chat client. If we go and take a look at our agents here, right? You're going to see that we're going to build this chat client agent, which is just one of the many types of agents that Microsoft Agent Framework supports. The instructions, as I mentioned, that's just a prompt. The name is just, effectively, a user-friendly name to address or reference that agent. But then if you take a look at two of them, right, you take a look at the chat and you take a look at tools. Chat in this case is our iChat client that we've been building with all this time, right? And so you just plug your chat client right in. And then from a tools, right, you can just effectively provide the same AI function at factory create tools. If it's MCP, right, you can provide the MCP set of tools. But all the things that you've been building with effectively are, just reusable here, right, as you sort of graduate in terms of complexity and needs when it comes to agents. And then at this point, right, at this point, you're just then using run async and the various methods that the agent framework provides you, right? But it all starts with those core building blocks and those primitives. Again, as I mentioned, you can effectively get a little bit more fancy, right? So you can take an agent and, for example, you might have multi-step workflows. I think you saw from the previous um, session with Squad, right? You're going to need ways to orchestrate these various agents. One of the ways that you can do that is via workflows. And in this case, right, you just have three different types of agents. You use this agent workflow builder. You can then call the workflow itself as an agent, right? And then use the workflow or invoke the workflow like an agent itself. If you want to go ahead and deploy to Foundry, right, you can certainly do that. But you can honestly deploy this wherever you want. In terms of protocols, the agent framework also provides you with some nice convenient methods, which I think you may have seen during Dan's talk with AGUI and things like A2A protocols and responses protocol, right? So there's a lot of things that Agent Framework sort of adds on top, to kind of help you build and deploy these agents. But again, at the end of the day, it's all built on those same core set of principles. All right. So that brings me to the end. So like as I said, and I didn't but for example, right, like there's a whole bunch of samples that are associated with all of these individual concepts that I talked to. I won't go through each of or run all of these because one, I have the output here, and you can sort of go take a look at all of these and run them on your own time. But what I do want to show you here is one of the things that we ship, right, just to make it simple to grok, right, like what all these pieces are, how they all sort of fit in. There's one that I didn't talk about, but I will sort of mention in the context of this demo. But one of the things that we ship is this .NET AI chat template, right? And effectively, what it is, it's a chat UI built with Blazor, right? It leverages AI models, so it's leveraging the IChatClient. It has a data store, right, where it just stores information or ingest. It has a set of PDFs, right, that it ingests, and we're using the Microsoft.Extensions data ingestion set of primitives. So we also provide, we're currently in preview, a set of ingestion primitives for building ingestion pipelines to get your data into some sort of vector data store. We're using functions, things like MCP. All of it is sort of orchestrated using Aspire. And then evaluation is not something that we have as part of it, but it's something that you can sort of add. And we have tons of documentation that kind of shows you how to add evaluations. And so it's actually quite simple to get started on your own, right? You would just basically install the Extensions AI templates, package or tool, and then you just say .NET New AI Chat Web. You have the template available. Prefer Aspire because that's gonna, it makes a lot of things easier. And you just hit do Aspire run, right? If you have this Aspire CLI installed. And what you end up with is, if I switch back over to my code here, is Aspire run. Oh, it should be in demo. So let me go ahead and run that. Then it's going to take a second here to pull up. While that's loading, right? So as I mentioned, this is the repo that I was sharing. You're going to see all the samples here under the samples directory. And so, you'll see things like, how do you use Ollama, or we didn't cover image generation, but these are samples that, you would use to effectively generate images based on some prompt. Okay, so let me go ahead and copy this and then open up a new window here. Okay. So this, I'm sure you've seen this many times before, but you're going to see the, all of your resources here over in the Aspire dashboard. In this case, I'm using Azure OpenAI for my model connections. This is our Blazor application, right? And then I am using an MCP server, and this is MarkItDown. This is a library from Microsoft that effectively provides you with the ability to convert and parse documents in various formats. So whether that's Office or M365 documents like Word, PowerPoint. You can also do PDFs. A wide variety of file formats. You just run it through Markdown, and it will turn that particular the source file into Markdown. That makes it easier for the your AI application to then process, right? And so in this case, we have a set of documents. We can go ahead and chat with it. In this case, what I'm going to do is I'm going to ask it, which sensors does, or what type of sensors does the watch have, right? And so what I expect here to do is it would go ahead, leverage some of our ingestion pipeline components to ingest the documents that we provide out of the box. Once they have been ingested, it then goes ahead, it's leveraging MarkItDown. Once that's ingested, it will then try and generate an answer. So you see it's loading the relevant documents, and it's going to take a second here. But in the meantime, while this is going, let's take a look at the traces. You can see here that we made that request. Our application has made requests to OpenAI, as well as our MarkItDown MCP server. So that's that ingestion piece, right, that you're seeing here in real time, right? If we were to drill in, you can see there's sort of that initial request, right? This is my system prompt. This is the question that I asked it, right? And now it's basically just calling on MarkItDown, generating embeddings, right? Using the IEmbeddingGenerator. This MarkItDown is actually, if I were to go back to the code, right? Let me see if I can sort of show you that piece. But if I go to here, web services, just semantic ingestion, data ingester. So if you take a look at these things here, we have this ingestion pipeline. So this is one of the other primitives that I didn't really go over, but it is something that we're providing, and very similar. The concept is pretty much the same, right? We want to provide you with a contract that is flexible enough that you can have different providers like MarkItDown, PDF Pig, the many other libraries that are out there for parsing. Chunking and basically processing the documents, and then this vector store writer, what this is doing is actually leveraging the vector data set of primitives, right, to enable you to just plug right in any sort of vector store, right, that you're using to store your embeddings, right? So once you've defined your pipeline, which readers you want to use, the chunkers that you want to use, where you're going to be writing your data out to, right? You just do pipeline process async, and that's effectively what's running this processing service that you saw here, right? Um, Once this is done, which I think it is, right? So we're going to see that's our system prompt, this is our user request. Then our system comes back to us, right, with our citation. And then what we see here is, obviously the response, um, right, which points us directly to the document in question, right? And so I would highly encourage you, if you're interested in seeing in action how all these pieces kind of fit together, go ahead and download the template, the AI chat template, and just start playing with it, right? Because that really shows you end to end how all of these different pieces compose. Last but not least, I sort of end on things that we are looking at next. So I kind of briefly touched upon ingestion, right? But one of the things that we often hear from customers is that PDF ingestion tends to be a problem. And by no means it's definitely an unsolved problem across the board, right? Not just .NET. And so some of the things that we're doing here to try to address is, making it easier for you to use different types of processors as you're reading the data, right? To provide, because when you read a PDF, if it's just text, it's relatively easy, right? You just parse in sequential order, read through the text. But what if you have columns? What if you have images? What if you have tables, right? Like, how do you actually extract and basically chunk your data into smaller pieces that then can be searched while preserving meaning, right? And so one of the things that we're doing here is, through this data ingestion set of abstractions, providing, some ways for you to more easily do that, right? And then on the retrieval side, right, we're doing something similar. And so the retrieval piece is basically the other side of that. So what I showed you in the sample and what we're using in the sample for the most part is, vanilla RAG, if you will. It's just, user query, go look at my data store, compare, and then return, return a set of, highly ranked results. The problem with that is, similar to ingestion, it doesn't capture nuances. It doesn't capture, intent behind the user. It doesn't really filter things correctly. And so you effectively need your retrieval to not just be a naive search across your data store. You really need the retrieval piece to be a pipeline, right? And so if we look at the ingestion piece, right, we have the read portion, which is just one of the sort of stages of a pipeline. And this is just opening a document and reading it. The chunking piece is, again, another stage of a pipeline. And this, you can effectively build your own set of processors for doing the chunking, right? Whether you want to do it based on, sentence length, whether you want to do it based on semantic meaning, whether you want to do it based on headings, it's going to change. But the point is, regardless of what strategy you're using, it should be pluggable. Same thing with enriching, right? So, like, for example, like, let's say that you have a chunk, you know, to make it easier to search, it might be nice to provide an AI summary of that particular chunk, right? And so very similar with this enrich chunker, right? You want to be able to plug in, right, any sort of enrichment strategy that you want. And with the writing, you want to be able to write to, any store effectively, whether that's Cosmos, Azure Search, Quadrant, right, SQLite. You want to be able to write to these, regardless, and just plug right in, right? So all these pieces are interoperable and pluggable, with the end goal of ending into some sort of like data store, right? And uh, the retrieval piece is very much the same, right? So rather than just doing like a naive search, one of the things you might do is you might do a query rewrite. So in comes your question, and then have AI rewrite or expand the query into like multiple related queries and kind of do like a fan out search. Even though it may not be relevant, it's fine. Just go ahead and cast a wider net than what you would normally capture with just your question. And then based on the result, you just go ahead and reorder them, re-rank them based on whatever strategies that you want to do. You can even then add another sort of like verification loop here that makes it easier for you to, to either like continue this loop until you find better answers. And then ultimately what you want to end up with is better context, right? So you provide more grounded, more relevant answers. Um, And so to close, right, what we went over today were the six, generally the six building blocks that, generally most AI applications need in .NET. We cover things like, the models with extensions AI and the chat client, the data piece with the vector data and the data ingestion set of components, tools and MCP with, again, the chat client and the MCP set of SDKs, the middleware piece, evaluations with the extensions AI evaluation set of libraries, and culminating with the agents.ai, the Microsoft agent framework set of packages. All this is already available in .NET. All this is available for you to go and build on top of. And so, really we want to make sure that you have what you need. And more importantly, right, that we are enabling the ecosystem, enabling you to compose these various pieces to be successful building AI apps. So as I mentioned the call to action here, go try the chat template because that's really the thing that's gonna like really allow you to play and see how all this stuff sort of fits together. If you want to learn more, we have this hub in Docs in Microsoft Learn. You just go to learnmicrosoft.com.net AI. All the samples, the presentation, everything is in this repo. Let us know, reach out if you have any questions or feedback. We love to hear it all. And yeah, that does it for me.